And the next custom utility that I wanted to show you is about carbon emission calculator. This feature allows calculating and summarizing carbon emissions for electrical systems of a facility that operates in various modes. For this demonstration, I will use this simple data model of an electrical system that operates in normal and emergency conditions. In smart electrical, they are called operating cases, where in this example the utility power supply will assume a normal operating case and backup generator will assume kicking off in case of the emergency. You will have to define equipment with the loading requirements for each operating case. For instance, looking at the common property of this motor, it has 7.5 horsepower rated power with low efficiency. Getting to manage operating cases window, you define it as the continuously operating in the normal case only. Operating heater common property has been defined with 3 kW of power, which operates about 70% in the normal case and 20% in the case of emergency. Also, note that power cables are also counted as carbon emitters, considering their physical properties such as resistivity and length, as well as load and ampacity during the operating conditions. Now you can run custom add-on program and perform the calculations. That will process the qualified electrical equipment and connected power cables, and then calculate carbon emissions produced by each individual item for the cases it is assigned to operate at, and then in this bottom section it will display the total summary of carbon emissions per each operating case. So here you will find power loss CO2, which is a summary of carbon emissions on base of the equipment power losses, consume/output power CO2, which is a summary of carbon emissions on base of the equipment consumed or generated power. In addition, the summary result will display the overall ratio, which represents the percentage of the power loss CO2 compared to the total consumed/output power CO2, which basically reflects the estimate of operating efficiency. You can view details in the upper grid, which allows to trace the details of the calculations for each individual item. For example, this motor 11M4 operates continuously during the year and consumes 8.25 kW of active power. The power losses of the motor is calculated as 1 minus efficiency and the result multiplied by the consumed active load. The accumulated loss of power per year is calculated as power losses per item multiplied by hours of operating per year and measured in kilowatt hours. So ultimately we get the carbon emissions calculated on base of the motor power loss as annual power loss multiplied by carbon emission factor and on base of the motor consumed power, which is a result of multiplying consumed power by carbon emission factor and by hours operating per year. Pretty fast, right? Other items like transformer, generator, cable and others are calculated using formulas applicable for the individual equipment type. If you want to analyze any subset of the equipment items, you can apply filters that will dynamically recalculate carbon emission summary for a filtered subset of the items on the window grid. You can also take advantage of the intelligent SLD drawing to highlight equipment which carbon emissions exceeds a certain value. So to do so, you will need to open a display set tool, where you can define filters with the boundaries of the CO2 regulations in your area, let's say 30,000 kilograms per year. Click and apply will highlight the items which are exceeding the CO2 values. That's all I wanted to show you today, but if you want to see more, please visit my YouTube channel. Thanks, and I'm passing the control over.